Good afternoon, good morning, good evening, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. In today's lesson, we are at Copperbelt University. Shout out to Larry Ngoma for requesting for this lesson. This is a Physics 110 Introductory Physics. This is tutorial sheet 2, 2023, and that is on scalars and vectors. All right, so if you haven't already, please subscribe to the channel, leave a like, comment, and share the lesson so that people will get the same benefit that you will from this lesson. All right, so this is physics. So let's go on with the lesson. So this tutorial sheet is categorized into 3 sections. All right, so the first section is about vector addition and subtraction, as you can see. Then the second section, I would say, is about finding the direction of the vector. Then the third section is about finding the resultant or the magnitude of a vector. So those are the 3 things that you will learn in this lesson and the following lesson. So stay tuned. So in this lesson, I hopefully will cover vector addition and subtraction and a bit of the magnitude of the vector. All right, then we'll do other questions as well so that you are familiar with that. All right, so let's look at question number 1 here. So question number 1, let me see, can you see it entirely here? All right, let me just put it like that. So question 1 here reads, a vector A has a magnitude of 10 units and makes 60 degrees with positive x-axis. All right, just move it a bit here. Okay, vector A has a magnitude of 10 units and makes 60 degrees with a positive x-axis. Then we have vector B that has a magnitude of 5 units and is directed along the negative x-axis. So basically what we have here is a simple question, and for physics what you want to do is you want to first try to transcribe a diagram from the question, or transcribe the question into a diagram. That way it will be easier for you to solve the question. So me transcribing this question into a diagram, I would have to draw an x or y plane. Let me draw it in red. Let me draw my xy plane in red. So I would have to draw an xy plane like that. Then A is 60 degrees. So this segment on the xy plane are in 90 degrees. So this is 90 degrees. I mean, this is 90 degrees. This is 90 degrees. This is 90 degrees. And that is 90 degrees. And altogether, that adds up to 360. All right, so A is 60 degrees. It is 10 units. So let me use black for that. All right, so A is that is the magnitude. That is A. That is A, and has a magnitude of 10 and is at 60 degrees from the x-axis. Then we have B that is 5 units and is along the x-axis. So that is 5 units along the x-axis. That will be along the x-axis, 5 units like that. So how we count angles for vectors, we always start from the positive x-axis when determining the angle at which the vector is at. Okay, so when determining the angle at which the vector is at, we always count from the positive x-axis until we meet the vector. So for instance, A, we count from this point to where the vector is at. So for B, it will be from this point to where the vector B is at. So that angle, that is 180 degrees there. All right, so those are the angles. So from here to there, that is 180 degrees. So that is 90 plus 90, 180. From there to there, that is 270. From there to there, that is 3. From here to there, that is 270. From here to there, that is 360, like that. So these are the angles of A and B. So now for us to add or subtract vectors, we have to resolve the vector A into two components. So A, for it to be added, it should have an X component and a Y component. Same applies for B. To be added to A, it should have an X component and a Y component. Now, how are we going to do that? So we are going to create a simple diagram that I'll just make here. So that will be X, say X component, and that is Y component. And for each of these components, we have our A and our B there. All right. So for A and for B, we have our X component part and the Y component part. When we do this, it will help us to find the sum. All right. So for the X component of A, for us to find the X component of A, we look at where A is. So we get the magnitude of A. So the magnitude of A is 10 units. So we write there 10 units. Then for X components, we always use cos. So we say cos where the A is, or the direction of A. So A is at 60 degrees. Remember, we always count from the positive x-axis to where A is. So from this point to that point, that is, we've already been given, that is 60 degrees. So that is 60 degrees. Then to find the Y component of A, we again write the same magnitude, which is 10. Then what changes is just here. So now we are using sine 60 degrees. So that is the X component and the Y component of A. So for B, we do the same thing. We look at the magnitude of B. So the magnitude of B is 5. So for the X component, we say cos the angle at which B is at. So we count from the positive x-axis until we touch B there. So that is 180. So we do the same for the Y component. We write everything the same. We just change the cos to sine 180 degrees. And that is just about it. So from here now, what we're going to do is for B, or let me start with A. For A, we have the X component, which is 10 cos 60. Okay. Then the Y component, which is 10 sine 60. So always the X component on top, the Y component at the bottom. So now this is actually equal to, when we simplify, cos 60, that is half times 10, that will give us 5. Sine 180, that is 0.8660. So times that will be 8.66. All right, so that is A. Those are the components 5 and 8.66. So now we do the same for B. So let me just move this here. I hope you'll be able to see there. So that is A. Then for B, we do the same. So B will be equal to the X component of B, that is 5 cos 180. Then we have 5 sine 180, which is basically just equal to, let me just put it right here. So which is just basically equal to 5 times cos 180. Cos 180 is -1. So -1 times 5, that would be -5. Then sine 180 is 0. So that would be 0. And yeah, so that is basically A and B. Then the addition part and the subtraction part is very simple. So let me just do it here. So if you are adding, let's say, so let me just put a few examples here. So if you have A plus B, so you start with your A. What is your A here? That is 5 and 8.66. All right. Plus, what is your B? That is -5 and 0 there. So adding the 2 will get this. So we add across. So 5 plus -5, that will give us 0. This is 6. 8.66 plus 0, that would be 8.66. All right, and that is the sum a plus b. For the same reason, when you have a minus b, you start with your a here. Your a is 5,8.66 minus your b is -5 and 0. So you do the addition there. So you do the addition, that will be 5 minus 5, so that will be 10. Then 8.6 minus 0, that will be 8.6. So that is your addition. Another example that is not there, maybe you have b minus a. Again, you do the same thing. You start with your b. In this case, this is our b, -5 and 0, minus our a, which is 5,8.66. Let me just put it up there. 866. Then you just do the same thing that we've been doing, which is this minus that will be -10. This minus that will be -8.66. And that is basically what vector addition. So this is the process that we'll be taking for adding two vectors or subtracting two vectors. Now we come to the issue of finding the angle of the vector or the direction of the vector. All right, so for whatever vector that you have, for you to find the direction. So for instance, this vector has a component, the x component and the y component. That is a plus b. A plus b has the x component and the y component, and you want to find the direction of a plus b. So to find the direction of a plus b, you have this a plus b. So the direction is just the angle of a plus b, which is equals to theta, which is equals to the tan inverse of the y over the x. All right, so in this case, if we're looking at the direction of a plus b, our x is this part, the 0, then our y is this part. So theta will be equals to the tan inverse of y, which is y. What is y here? y is 8.66 divided by 0, and this is undefined. When you punch this on your calculator, this is undefined. When it is undefined, we know that the angle at which it is at for tan, that is 90 degrees. All right, so this is at 90 degrees. Yeah, so if it is undefined, like in this case, we know that the angle is at 90 degrees. So that will be the direction of this one. It is at 90 degrees. This is because the tan has asymptotes at 90 degrees and 270. So since this is positive, so we are in the positive 90 degrees. If we had a negative there, then if we had a negative here, then what we would have is 270 there. All right, so that is the direction of a plus b. So you do the same for a minus b. A minus b, so that is theta is just equals to the tan inverse of the y-axis. Let me just draw this. Why am I missing that? All right, the y-axis, which is 8.66, then divide by the x-axis, which is 10. Then you just compute that on your calculator. Tan inverse of that, you punch, and that will be your answer. So that is how you find the direction. Then coming to the magnitude. So the magnitude will be this just similar. So for you need to have a vector in this form first of all. So if you have a vector in this form, then the magnitude, for instance, this is the vector a minus b, b minus a. B minus a, the vector of b minus a is -10 and -8.66. All right, this is their sum. Then to find the magnitude of this vector, we're going to put the modulus of b minus a, that is the denotation for the magnitude. So this is just equal to
the square root of the x part, which is this part, or let me just write the formula, the square root of the x part plus the square of the y part. So the square root of the square of the x part plus the square of the y part. So that would be the magnitude. So in this case, x squared, that would be negative 10 squared. So on your calculator, you should be very careful, put that in parentheses. So negative 10, then you put the brackets, then you square, plus y, which is negative 8.66, then you square as well. So put that in brackets. So negative 10 squared plus that squared, then you find the root of the answer, and that will be your magnitude. All right, so when you simplify that on your calculator, that will be your magnitude. So this basically explains question 1 and 2. So question 1 and 2 are already solved just from the explanation there. So go through the video. So to find the direction I've explained. So this is the vector that we have. So for A, let me just help you. For A, the angle at which A is at is this angle from the x-axis to where A is. So this entire line is 180 degrees. Okay, so if this is 180 degrees, what angle can that be? So that is 180 minus 25 degrees. So this is the angle. This is the angle 180 minus 25. That will give you the angle at which A is at. And for you to find the angle at which B is at, again, you count, or you start from the positive x-axis all the way to B there. All right, so from the positive x-axis to B, when you reach here, that should give you 360. So this angle is basically 360 minus 20 degrees, and that will be your angle for B. And you just resolve as we were doing here. So for A, you resolve for A. For A, you have 30 cos what is 180 minus 25? That will be 155. All right, so that will be 155. That is x component. Then AY component, that will be, you just get the same thing. So that is 30 cos 150, I mean sine 155. So you do the same thing. That will be 30 sine 155, and that will give you the y component. So you do the same for B. For B, the x component, that will be 20 cos, this will give you what? That would be 340 cos 340. That is for the x, and you do the same thing for the y. Then you start doing what we did here, and you're good to go. So that is about it for question 1 and 2. Have a good evening. So for those that want to get in touch, my WhatsApp line is on the screen there. It's on the screen, so you can do well to contact me. You can even send me the solution for question number 2 here, and I'll be able to mark your work. So have a great evening.